First bit here is easy enough. The question says calculate the braking force on the car, and it must be the braking force that's causing the deceleration. In other words, we can use Newton's second law in the direction of the acceleration. In other words, the force which is acting must equal the mass times the acceleration. Now, the force then is going to be, well, there's the mass of the car, which is 600, and the acceleration is actually a deceleration in this case, which in other words is -5. In other words, it must be minus 3,000 newtons. So the braking force is acting sort of against the motion. The car is, if you like, moving this way. The braking force is acting against that, and it has a magnitude of 3,000. Question then says, what's the graph going to look like if the initial braking force is less than it was to start with over here? Okay, initial braking force is less, and it gradually increases. Okay, so let's have a think of what's happening here. Basically, the braking force is what's providing the deceleration. If you reduce the braking force, so if I'll call that F, if you reduce F, it means that you reduce the deceleration. So reduce the deceleration. And that's going to mean that you basically reduce the gradient to start with. So let's have a look at what that's going to mean for the graph. So the gradient, at the moment, the gradient is looking like that over here. So the gradient to start with here is going to be less than that. So let's say it's going to be more like that. And what happens then is that the braking force gradually increases. Now what that means is that the gradient is going to increase. In other words, it's going to become steeper, obviously in a negative direction. So what's going to happen is that the graph is gradually going to become steeper and steeper and steeper until the 4 seconds have elapsed.